Hello everyone, welcome to this lecture on artificial intelligence and machine learning. In today's video, we are going to learn the basic concepts of machine learning. Machine learning is one of the most rapidly developing technologies in today's world. It is being widely used in different sectors such as automobiles, healthcare, finance, manufacturing, social media, e-commerce, and many other applications. In this lecture, we will understand what is machine learning, why did we need machine learning, how does machine learning works, what are the important components of machine learning, what are the different types of machine learning. Machine learning is a branch of artificial intelligence that enables computers to learn from data and experience. In traditional programming, we generally provide rules and data to computer, and the computer produces the required output. But in machine learning, the approach is different. We provide data and the expected information or outcomes, and the machine learning algorithm identifies patterns from the data and develops a model. This model can then be used to make predictions or decisions when new data is provided. Machine learning is continuously growing and gaining importance in different business and technology sectors. The main idea is very simple. Instead of explicitly programming every rule, we allow the machine to learn the rules and patterns from the data. Now, let us understand the basic definition of machine learning. Machine learning is a growing technology that enables computers to learn automatically from the past data. ML algorithms are used to build mathematical models from historical data. These models can then be used to make predictions or performing specific tasks. For example, consider an email application. Suppose we receive hundreds or thousands of emails. Some emails are normal messages while others are spam. Instead of manually writing rules for every possible spam email, a machine learning algorithm can learn from previously classified emails. After learning from this historical data, the system can predict whether a new email is spam or not spam. Similarly, ML is used in image recognition, speech recognition, email filtering, automatic tagging, recommendation systems, fraud detections, autonomous vehicles. So machine learning allows computers to make intelligent decisions based on the patterns from the data. Now let us understand an important question. How does machine learning actually work? The basic process consists of three major steps. First, the system collects historical data. Second one, the machine learning algorithms analyzes this data and builds a prediction models. Third, when new data is given to the system, the trained model produces a prediction or an output. So we can represent the process as historical data to learning algorithms to model, and finally we get new data and prediction. Let us take a simple example. Suppose we want to predict the fuel consumption of a vehicle. We collect historical data such as vehicle speed, engine load, vehicle weight, road condition, and engine performance parameters, and previously fuel consumption data. The machine learning algorithm analysis these data and it builds a mathematical model representing the relationship between the input parameter and the fuel consumption. Now, the vehicle condition is provided. The trained model can predict the expected fuel consumption. This is the best or basic working principle of machine learning. Now, let us ask an important question. Why do we need machine learning? The need for machine learning is increasing because many modern problems are too complex to solve using manually written rules. Humans have limitations. For example, imagine that we have millions of records. It is practically impossible for a person to manually examine every single data and identify all possible patterns. This is where machine learning becomes useful. Machine learning algorithms can process large amount of data and identify patterns automatically. The algorithm can be trained using historical data and can then construct a model for prediction or decision making. This can save significant amount of time consumption and human effort and cost of the work or job. Some real-world applications like self-driving vehicle. In this vehicle, machine learning can process information from cameras and other sensors to support vehicle decision making. And another one application, fraud detection. Financial systems can analyze transactions and identify potentially suspicious activities. And face recognition. It can identify patterns in facial images and recognize individuals. Another application is recommendation system. Laptops such as Netflix, Amazon, Geo Hotstars. These users' behaviors and preference to recommend relevant content or products. So machine learning is not simply a theoretical concept. It is already being used in many real-world systems. Now let us define machine learning. More formally, machine learning is a technology used to train machines to perform tasks such as prediction, recommendation, estimation, classification, decision making based on historical data or past experience. The important idea here is learning from experience. A machine learning system does not necessarily need a programmer to specify every possible situations. Instead, the system learns patterns from the available data. There are three important aspects of machine learning. First one, task. Second one, experience. And third one, performance. Let us understand each one. Task. The task represented by T refer to the problem that machine learning system is expected to perform. For example, predict vehicle speed, identify the object, classify an email, recommend a product. These are examples of tasks. Experience. The experience represented by E refers to the historical data or previous informations from which the machine learns. For example, previous vehicle sensor data can act as the training experience for an automotive machine learning system. Okay. Third one, performance. The performance represented by P, it indicates how well the system performs the given task. For example, if we are predicting vehicle speed, prediction accuracy can be used as a performance measure. Therefore, task tells us what the machine has to do. Experience tells us what the machine learns from. Performance tells us how well the machine performs. These three concepts are fundamental to understanding the machine learning. Let us understand task, experience, and performance using an example of robot driving system. Robot driving system. Imagine that we want to develop a robot or autonomous vehicle that can drive on a public 4-lane highway. Okay, it can drive on public 4-lane highway. Here, our machine learning problem can be represented using three components: task. The task is driving on public 4-lane highways using vision sensors. So, the machine has to learn how to drive based on information obtained from vision sensors or cameras. Second one, performance. Now, we need to determine how well the robot is performing. Okay. One possible performance measure is the average distance traveled before an error occurs. If the vehicle can travel a longer distance without making an error, its performance can be considered better. Okay. Next one, experience. That is training experience, E. Finally, we need training experience. The training experience can consist of a sequence of images and steering commands recorded while observing a human driver. The system learns from these examples. It observes the road images, understands the corresponding steering commands, and gradually learns the relationship between visual information and driving actions. This is a very good example of how machine learning can be applied to an autonomous driving problem. Okay, now let us move to another important topic: types of machine learning. Machine learning is a subset of artificial intelligence, and it allows machines to learn from data, improve their performance based on their experience, and make predictions. ML algorithms works with data. The data is provided to the algorithms for training, and the algorithms build a model and that can be perform a particular task. Based on the learning methods, machine learning can be broadly divided into 4 types. Okay. There are supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. Let's briefly identify these 4 categories. The first type is supervised machine learning. In supervised learning, the algorithms learns using training data where the desired output is known. In simply, the system learns from examples where both the input and corresponding output are available. For example, suppose we provide images of vehicles along with their labels: car, bus, truck, and motorcycle. The algorithms learns the relationship between the images and its features and their corresponding labels. Later, when a new vehicle image is given, the trained model can predict its category. Okay. And supervised learning is commonly used for tasks such as classifications, regression, and predictions. The second type is unsupervised machine learning. Here, the system is given data without predefined output labels. The algorithm tries to identify meaningful patterns or structures within the data. For example, imagine that we have a customer data, but we don't know the customer categories. So, an unsupervised learning algorithm can analyze the data and group customers based on similarities. This process is commonly called clustering. Okay, so the major idea is supervised learning learns from labeled data, whereas unsupervised learning identifies patterns in unlabeled data. Okay, these are the major difference between supervised learning and unsupervised learning. The third type is semi-supervised learning. As the name suggests, it combines characteristics of supervised and unsupervised learning. In many real-world situations, collecting labeled data can be expensive and time-consuming. However, a large amount of unlabeled data may be available. Semi-supervised learning can make use of a smaller amount of labeled data together with a large amount of unlabeled data. Okay, combination of small amount of labeled data and large amount of unlabeled data. This can be useful when manually labeling a large data set is difficult. Okay, for example, in an image recognition application, only some images may be manually labeled, while thousands of other images may remain unlabeled. Okay, a semi-supervised approach can use both types of information during learning. Okay, finally, fourth is reinforcement learning. In reinforcement learning, an agent learns by interacting with an environment. The agent performs an action and receives feedback from the environment. This feedback can be in the form of a reward or penalty. The objective is to learn a strategy that maximizes the total rewards over time. Let us connect this with autonomous driving Imagine an autonomous vehicle learning how to navigate a road. If the vehicle takes a correct action, it can receive a positive reward. It makes an incorrect decision, it may receive a negative reward. Through repeated interactions and feedback, the system gradually learns better actions. Therefore, reinforcement learning is particularly useful for decision-making problems where an agent needs to learn through interaction. Thank you. Thank you for watching this video.